Today, let's talk about significant figures. So, significant figures is closely related to the idea of precision, and it's an implicit way for us to denote the precision of a measurement. And we do this through the number of decimal places we put in our measurements. So, for example, if I have 1.25, we would say this has 3 sig figs. That's short for significant figures. You might even see sig digs, significant digits. But this says we have 3 significant figures, and we know whatever measurement we're doing to the 100th decimal place. But if I do another measurement and I have 1.255, we'd say this has 4 sig figs, and we know this to the 1000th decimal place. So what this means is the number of sig figs, we have an extra sig fig here, tells us that our measurement, or our tool of measurement at least, is more precise. So that's what significant figures is it's the number of digits in a number that tells us about the precision of our measurement. But there are rules for what makes a value significant. And so I'm going to go through those rules right now. The first one, the easiest one, is that all non-zero numbers are significant. Underline that. All non-zero numbers are significant. So that one's pretty straightforward. It gets a little more complicated when you start bringing zeros into the picture. So zeros are significant, except if, so there's a big except there, except if they are leading zeros before and after the decimal place. So what does this mean? Well, leading zeros would be something like, if you have this before the decimal place, 0.1. This is a leading zero before the decimal place, not significant, therefore. You could have 0.01. Both of these are not significant. This one's after the decimal place and this one's before. Not significant. So, leading zeros are not significant, but when are zeros significant? What have I left out here? Well, zeros are significant if they have two numbers, non-zero numbers in between or on the outsides and they're in between, then they're significant. So these are significant. That's pretty messy. If you write 5, 0.00001, these are all significant in that case because they're between two values that are also significant. So those are rules for zeros. Now there's one more thing to talk about with zeros, and that is going to be in the third rule, which are trailing zeros. So these are zeros that come after the end of numbers. So these are significant in decimal numbers. So they are significant in decimal numbers. Example being 21.000. So you have a decimal here, so these zeros are significant. But they are not significant in integer values. In fact, it's a little more complicated than that. They are ambiguous. So we don't know whether they're significant. And for the most part, we just say they're not. We assume they're not. So example, if you have 1,500, these are ambiguous, and it's safe to just assume not significant. Now this is maybe difficult to wrap your head around. And I know it was for me when I first learned it. And I'll do an example right now to show you why this is the case. So say you're doing a measurement and you measure something to be 10 centimeters. Now, in order to understand this, remember that what significant figures is doing is telling you about the precision of the measurement, not about the measurement itself. So if you could write this 10 centimeters as 0.1 meters, right? And as we've established, these are not significant, but this is just converted from this. So this is also not significant in that case, because it has nothing to do with the precision of the measurement. It's just telling us the scale of our measurement. What would tell us about the precision of this measurement is if we said, 10.0 centimeters and then 0.10 centimeters, right? So now we know we have some precision here, whereas this 0 and this 0 are just placeholders for the scale of what your measurement is. So that's why those values are not significant for the most part and are ambiguous most of the time. So one final thing to drive the point home. Let's say you have a meter stick. And the precision, so you have a meter stick and the precision is 1 millimeter. So you've got ticks of 1 millimeter. How would you write this in terms of significant figures to express that precision? So you have, let me just write out 1 meter. So you got 1. So this would be 1 meter. And you have ticks of centimeters. So you can write that. So this denotes your centimeters. And then your precision goes down to the millimeter. So you have another decimal place to signify your millimeters. And then you might think that we stop here, but actually we put one more decimal. And this has to do with our uncertainty. So the last number in your decimal, so your last decimal point represents the limit of your measurement. So when you quote this final number, everyone knows you're not as certain about these numbers. These you know for sure. And then this one is not 100%. And so that would be how you do it with the meter stick. If you didn't know up to the millimeters, you just take it off. You got your meter, your centimeter, and then you've got your uncertainty. And so that's a little bit of an intro to significant figures. And I think the most helpful way to learn this, rather than me talking at you, is doing examples. And I will be doing that in the next video.